Alright, so here we have two fairly large monomials, 98, well you can read, I'm not going to read it up for you. And so what I'd like you to do is actually just start by pausing the video and start by writing out all the factors of 90, all the factors of 72, and then all the other common variables, and try to come up with the GCF on your own. I'm going to wait 3 seconds and then show you how I did it to get the answer. Okay, so I've written out all the factors of the coefficient there, 90 and 72. And if you start scanning, looking at the bigger numbers first, and keep looking until you find a set that matches. In other words, I have 90 here, 72, 45, 36 doesn't work, 20, 30, 24, no, 18, 18. Ha, there we go. There is my greatest common factor just for the coefficient. So I know my GCF is going to be 18 something, okay? And then to find the rest, I'm going to look at the variables. In other words, I have, looking at the a's, okay, I have a cubed, which is like 3a's as factors, and a squared is 2a's. So that means 2 is common to both. So that means that for my GCF, a squared will be common to both. I'll look at the same thing for the b's, okay? And for the b's, I notice I have 5 b's as factors. This is b times b times b times b times b, or whatever there are there. And then there's 3 b's that are factors here. So again, that's going to be b to the power of 3 because there's 3 b's common to both. And then obviously c to the power of 2, or c squared, since there's 2 c's as factors on both sides there. Okay? And there's how you get the greatest common factor. So 18a squared, b cubed, c squared. Okay? Now, there is another way to find the greatest common factor here. Rather than writing out that, all the factors and everything, it's called Euclid's method, I think, or something like that, whatever. Has some kind of math-sounding geeky term, and it actually works really well, and it's kind of fun if you're a nerd. So, here's an example of what I'm talking about. I'm actually going to use 90 and 72 because we already know the answer. I'm just going to show you how it works, and then I'll show you how you can do it with bigger numbers and why it's a better way of doing things. So let's take the smaller number and divide it into the larger one. Like that, in other words. Okay? So if you do that, well, okay, this goes once with 18 left over, 72. Okay, and I get 18 as a remainder. Okay? Now, so I didn't get a non-zero remainder. Okay? And that's the method, by the way. You take the smaller number, divide it into the bigger one, and then you take the remainder and divide it into this one. Okay? So now I'm going to go 18 divided into 72. And lo and behold, it goes in exactly 4 times. Okay, 0. There's my 0 remainder. And then the dividend, or whatever this number here is called, that gives you a, the divisor maybe? Maybe it's the divisor. I don't know. Look it up. I really don't care. Whatever divisor or whatever that number is. I'm going to look it up right now. 1 second. Okay, yeah, it is a divisor. So whatever divisor gives you a gives you a 0 remainder. In other words, it works out perfectly. That divisor is the GCF. Just like before, we figured that 18 was the GCF. Here we've done it using Euclid's method as well. Now, why would you do all that when you can just go through and do the other way? Well, for larger numbers, it can be difficult to spot the GCF, and so this actually works out really well. Let me show you an example of what I'm talking about. So say, for example, you had these two numbers. You can't really see what the largest common factor is here, so you might go through and start dividing by 3 and then see what you get, and then divide that and try to break it down. And you could do that, and it would take just as long as doing Euclid's method. So why not do Euclid's method and get it right the first time without guessing? Okay, so same process, take the small number and divide it into the larger number, like that, and it only goes in once. Okay, we get a remainder of 156. I take my remainder and I divide that into my divisor. Again, it only goes in once. And so again, I take my remainder, put it into my divisor, and again, it only goes in once, 117, and I get a remainder of 39, and I take that, and again, this goes into that. You just keep doing the same thing over and over again. That's why it's called an algorithm. That's what it's called, Euclid's algorithm. And then if you do this last one here, you'll see that it goes in exactly 3 times. In other words, this divisor gave me a 0 remainder, so that's my GCF, 39. You probably couldn't have picked that out just by looking at it. So I'm going to have you try one in the next video here.